Alright everybody, welcome back to another Unreal Engine live tutorial. This is Ask a Dev. My name's Kevin. We try to do these every week. We've got just about the right amount of crazy to try to do live tutorials in Unreal Engine, which is always fun because Unreal Engine is a beast, so something always goes fun. I currently work as a senior principal tech artist at Riot Games, but this is a chance for me to learn a ton from the community by listening to your questions, stumbling through them with you, and hopefully we can all learn and do a lot of fun stuff together. So as always, thanks for checking out the channel. If you're new to the channel, appreciate it. Don't forget that a lot of our videos are in the live section. We do have pre-recorded stuff in the video section, but we do have a lot of our content in the live section as well. All of our content generally comes from community requests, whether through Patreon on Discord, so check out the links below in the description. And the chapters will be updated. Today, we are continuing our skeleton journey. We're going to be taking a look at virtual bones, but as usual, we're not going to just look at virtual bones because it's literally 2 clicks. We're going to be taking a look at virtual bones, control rigs, post-process anim blueprints, and some thread-safe animation stuff that I didn't even know about till some really smart people taught me. Off the rails, welcome to the stream. Good to have you back. So, quick audio check. Can you hear me all right? And then let's get going. All right. I am hoping Josh, welcome. Josh Styles is in the house. Thank you everybody for hopping in. It's good to see you all again. So today, if you recall, or if you haven't seen it from last time, we were talking about skeletons, and we had covered what sockets are, all those kinds of things you can do with them, some limitations, some of the advantages of compatibility mode and all that stuff. All that being said, today we're going to look at virtual bones specifically. Now, a virtual bone gives us the ability to do a lot of cool stuff. And the easiest way to explain it is a virtual bone is exactly what it sounds like. It's a virtual bone. It's added after the fact. And the general gist is it allows you to create a bone that follows a joint in your skeleton, but has a different parent. So let's say, for example, you wanted a bone to follow your hand, but be in the space of your root, for example. That's what a virtual bone does. And it has a couple unique things that are really cool for us to play with. A lot of times, if you look through the docs and stuff, they're used to help track a object in space independent of the hierarchy to help with things like additive animations so that you can get a proper track, etc. But we're going to use it today to do our VFX sockets thing. So as a recap, here we are. Also apologize up front. The cold thing is going around and I will try not to cough in the mic. So as a recap, we have our skeleton. And if you recall, what we were doing was we had, if we just shrink up these clouds, here's our head. If we right click, we can choose add a socket. This created a socket that was attached to our character's head, and we could move it above our character's head. And if we go back to our engine, make a couple of quick changes. And what we're going to do is in our blueprints, I just, for some reason, I prefer working with Manny. So I'm going to change this to Manny Simple. And we have our socket. And we're going to do something a little bit different this time. We are going to, hold on a second. Let's take a deep breath. Slow down, people. So far, we've just done a recap, right? We've added a socket. With a socket, we are able to attach particles, whatever we want to do. In almost every project I've worked on, the effects team likes to have different sockets that they can attach their effects to. So some of the typical sockets that are requested are an overhead VFX socket, a chest socket, a body or center of gravity socket, and usually there's one around the feet. Now, just attaching a particle to a socket, generally it's fast. You just add the socket and the particle will fall. The problem is the socket also inherits all of the rotation and translation of the bone that it's following. So for example, the head joint, which means that if I am looking at you and I look to the left or to the right, my V effect or whatever I have attached to the overhead socket is also going to move left or right. So there's some nuance to the request sometimes where they're like, hey, it'd be nice if it followed world rotations or the rotations of another joint, as an example. And we went over the problem with having a socket is there's no way to control that after the fact, but we can with the virtual bone. With virtual bones and control rigs, we can do that. That's what we're doing today. We're going to attach an object to our character's head as a means for us to have a practical example as an introduction to virtual bones, control rigs, and post-process anim blueprints. Whew. Okay, so we have our character in our viewport. We have the socket over their head. All I'm going to do is I'm going to add a plane to our character. And over on the right, in the sockets, I'm going to use the head socket. And when I do that, you'll notice that it travels to the head. And if I rotate this, I believe it's 90. I can get it to be flat above the head. I'm going to go minus 90 actually. Okay, and I'm going to put a checkerboard on here. Checker. Let's do this one. Okay, so you'll notice that this plane is a stand-in for our VFX, for example. It follows our character's head. It's part of our character, and as I move in the scene, you'll notice that it follows. It does exactly what a head socket should do. It follows in both rotation and translation, and also when we jump. But we want to be able to move this every single time for different characters. So in addition to giving us flexibility, a virtual bone also allows us to have changes based on the character we're working with. So let's switch this up a little bit. It's just like a socket, to create a virtual bone, all you do is right click and add a virtual bone. And you've got to pick the target bone. In this case is going to be the head. Now when we create a virtual bone, the way the naming convention works is the default is it's VB for virtual bone. The joint that it is effectively parented to, and then the joint that it is following. So this virtual bone is parented to the root but follows the head based on the naming. I wish the naming was a little more flexible. Epic, if you're listening. The spaces in the name and underbars and stuff, it'd be great to be able to use our own. But anyways, that's the way it works for now. So it's pretty clear. This is a virtual bone parented to the root that follows the head. And as you'll notice, it is sitting up here following our head. If we go back to our character, we can switch this plane to follow our virtual bone instead. And it is going to be down here at the bottom. Oops, I clicked wrong. Hold on one second. There we go. Virtual bone head. Now, unlike the socket, I'm not able to move that. Okay, so at first it seems like it's not as useful, but it actually is, and this is where the control rig comes in. So I don't want to freak anybody out, but we're going to hop into control rig with a very small introduction that you will be able to understand even as a beginner. Before we do that, let's properly scare you with what a control rig actually can look like and what it does. It's fun. All kinds of fun. Okay, so let's talk about what a control rig is. Control rigs are new. I'm trying to remember when they added them. It was either late in the 4s or 5s, but they're pretty much like full on adopted now. And basically what a control rig does is it allows you to create a series of controls and drivers and various rigging setups to change or manipulate or animate your character's joints. It is a means in Unreal Engine to effectively create a control rig, a marionette, a puppet to control your character's skeleton. And generally speaking, you can click on these and you can, depending on how these set up, whether they're FK or IK, you can pick these, rotate them, do whatever you need to, and effectively pose out your animation or your character, which then can be used to do level sequence animations, custom animations in Engine, all those kinds of things. What does this look like? Well, it looks nuts. So, this, for example, is the forward solve. And with the forward solve, it does a lot of stuff. It sets bone transformations based on controls that have been added. all these different things. As you can see, there's a whole lot here. We're not going into it this deep. We are going to do a very simple control a joint with a control rig. So let's do that. But this is how deep it can get. Full inverse kinematics, a whole bunch of rigging stuff. And you can look at the ones that come with the default projects as a point of reference for how deep the rabbit hole goes. But what we are going to do is we are going to go back to our meshes. We are going to click on our Mani. I'm going to right click and I am going to create a control rig for this. Okay, and we are going to call this control rig. Let's call this virtual bones. Virtual bone and virtual bone placement, just for clarity. I'd probably call it something else, post-process or whatever. Okay, and when we go into our control rig, let's open this up. For some reason, my machine is chugging. Okay, starts off pretty basic. Okay, we have our rig hierarchy is over here on the left, and we have kind of our execution, our blueprints, bunch of curves, etc. Now, this is the forward solve, and effectively, what we do in here can directly affect our joints. So, for example, if I wanted to rotate the spine joint, spine 2 I have selected, if I just connect this in, you'll see it already changed my spine. The reason it changed my spine is because I am setting the rotation of a bone. The bone I'm rotating is spine 4, and the value I'm giving it is 0. So you can see this has already affected my joint. Now, what we are going to do is we are going to use this to set the position of our virtual bone. Because unlike a socket, if you'll notice in here, I can't get to my socket. There's no way for me to manipulate my socket in a control rig, but I can get to my virtual bone. So I'm going to get my virtual bone and I'm just going to set the translation for right now. And if we take that and we connect it in, what's going to happen is when I compile this, if we pick our virtual bone, you'll notice that it is hard to see because it's now down at the origin. Let's see if I can make this bigger. It's down at the origin. It's kind of highlighted down there. Okay? But what we want to do is we want it to be above the head. So what we're going to do is we are going to get the joint's head. We're going to get this bone's, we'll get the bone, head, space. Here's its transform. So this is the bone transform, and what we want to get is its translation. So let's just connect the translation in. When we do this and compile, we should see our virtual bone is now up at the head. You see the green dot at the head? It's kind of hard to see, but let me zoom this out. So we can see now our virtual bone, as part of our forward solve, is being set to the same position as our head bone. But what we want to do, if you recall, is we wanted to put a little bit of offset in there. So let's do that. So what we'll do is we'll take from this transform and we're going to add. We're going to add, let's say 50 in Z, which in Unreal Engine is up. We're going to add 50 to it and we're going to connect that in instead. And when we do that, you'll notice that now my virtual bone is floating above the character's head. Okay, so we have effectively recreated the ability to offset our virtual bone like we do with sockets. You with me? Everybody with me? Now we need to connect this to our animation blueprint. So let's do that. Compile this. We can go ahead and save this, and then let's go to our third person character and let's take a look at our mesh, and let's go back to our ABP Mani, and then we're going to edit our ABP, our Anim blueprint for Mani. And what we're going to do in our Anim graph, you'll notice they actually already have a control rig in here. This control rig is used for the foot IK placement, so that when you're standing on an uneven object, your feet are still go to the ground and stuff like that. So we're just going to add another one in here. Let's do a control rig. Oh, by the way, before we do this, if we play you'll notice that the plane is in our character's face, right? It's not actually, our virtual bone is not being moved yet because we need the control rig to do that. So let's go back to the control rig and let's add in our control rig now. So we'll just drop it here in line, and I'm going to show you how to do this a little more cleanly later. And the control rig that we're going to use in this case is going to be our control rig virtual bone placement. Now the minute I compile this, you'll notice that the virtual bone pops up to be above his head. And if we go back and we play, you'll notice that our plane is now above our character's head. Now here's the trick. That's it. We got it. We've actually now used a very simple control rig plus a virtual bone to give us an overhead socket that we can attach things to. Now maybe you want to attach effects to it, maybe you want to attach, I mean there's lots of different things you could attach to it, but that's the overall point. That's what we've got. Now there's a couple nuances that we're going to want to do to make this a little more useful. I would like this not to follow the rotation of our character. And the reason for that is because if I put a VFX up there, or let's say I put a status symbol or something like that, I don't want it bouncing around. Every time we jump, it's going to animate like with the chin going up and down. So let's stabilize the rotation of this thing. How are we going to do that? There's a couple ways we can do that. So let's go through them. If you're just starting off, what you might do is you might think, I could do that on tick. And you would come in here and very quickly we would get tick. Let's go tick. Tick's not being used right now. And what we can do is we can get the plane and we can set the rotation of the plane just to be 0, 0, 0. And that's it, theoretically. Okay, so you'll notice now this plane follows the character. I'm not moving yet, so you haven't seen it, but you'll notice that it doesn't rotate anymore. It follows the character in translation, but in rotation, it is using the world rotation. And this is cool because if there's a status symbol or something, I want it always kind of facing a certain direction. Or, for example, let's say if you watch all the old cartoons, when a character gets hit in the head and they have the stars zipping around their head, maybe you don't want the rotation of the character's capsule plus the rotation of the system plus the rotation of the effects. Maybe you just all want it locked down. That's kind of up to the VFX artist. But so very quickly using tick, we've done this. Now, usually tick gives people the heebie-jeebies. And there's a couple reasons for that. Performance is a concern, and actually, interestingly enough, in our community so far, everybody is hyper aware of performance and not using tick for stuff like this. So what if we didn't want to use tick? How would we do this with our Anim blueprint instead? All right, so here's what we need to do. We need to set the bone's rotation in our control rig as well. So let's do that. Let's take this virtual bone, let's drag off, and let's set the rotation. And what we're going to do with this is if we connect this in, first off, if we set it, it's interesting, when you set it to global space and the value of 0, you would think that this would do the exact same thing that we were just doing, but I don't think it does. Let me just double check. We got rid of our tick. That's cool. When we play now, you'll notice that the rotation is pretty messed up. It's not actually taking the world rotation because what it's doing is, well, there's a couple things. One, we need to change this. We're no longer, this plane, actually incidentally, this plane doesn't even need to be parented to our character anymore, but just for, actually, we want it parented. I'm sorry, I misspoke. I don't need the 90 in here though. Okay, so we'll get rid of the 90-degree offset and we'll go play. Okay, so now our plane is rotated to 0, but it's still following our character. So in practice, what's actually happening in this control rig is global space isn't really global space apparently. So we need to actually set this. So how are we going to do that? Well, let's take this variable and let's promote this to a variable. And we are going to call this variable over here in my blueprint. Let's rename this from value to be actor rotation world space. Okay. And what we're going to do is we're going to make it instance editable and expose on spawn. Because what we want to be able to do is we want to be able to set this. So let's compile and save that. And then inside of our Mani blueprint, what we want to do is if we refresh this node, we can now over here and on the right, there's a lot of checkboxes you got to click for this stuff. Over on the right, you can now use the actor rotation world space. We can use that pin. So if we check that box, now we have an actor rotation world space we can use. So with that, we can just get, I believe we can get the rotation. Hold on a second. Not the vector. Oh wait, I'm in the Anim blueprint. My mistake. I'm over here. I want to, much like we did before, I want to promote this to a variable as well. So let's promote this to a variable. Okay. And we'll set this over here, and then we need to go into our event graph. And what we'll do initially is on update animation, as long as our character is valid, we're going to do all these things. Let's just add another pin to our sequence. And what we will do is we will set this to be actor rotation. Nope, that's not what we want. Let's get our character. From our character, let's get rotation. Get the actor rotation. Okay. Now, the trick is we need it. The actor rotation we have is in a rotator, and so we are going to convert that to a quaternion as a result of this and connect this in. Now when we do that, we're now getting our actor rotation, we're feeding it in, and then this variable is getting updated. That is getting fed into our control rig. Our control rig is taking that and it's using it to set the rotation. I do not believe this is going to work yet. Let me show you why. Let's compile and save all this stuff just so we have it. And what we're going to do is take a look at it, and you'll notice that this thing is still spinning crazy like, because what we actually need to do is in our blueprint, we need to inverse this, because we actually want to counter animate the actor's rotation. So let's take a look and see if we got that right. There we go. So what we've done here is we have now taken our virtual bone. It follows the head plus an offset, and then we have the added ability to counter the rotation to have it fixed to world space based on our actor's rotation by feeding that in and inverting it. So now we can use this to attach effects, status symbols, anything we want to. And you can get all kinds of fancy with this. If you want this to face the camera, whatever it is, whatever rotation you want to feed into this, you can. But the overall cool point here is we can actually set, using control rig, virtual bone positions, which also means that we can, in addition to having the compatibility mode to set head socket distances, we could also now have attributes on our character, float attributes for head size or positions or whatever you want to use to set this virtual bone location as an example. I thought it was a really cool thing to be able to do this. A lot of times the way this is achieved is a bone, a joint is added to the character skeleton in the DCC software like Maya or Blender. Those bones are constrained and then baked out, and you have all those animation curves and all those kinds of things. If something needs to be changed, you have to rebake all your animations. Not anymore. Through the use of control rig, virtual bones, etc., there's a way for us to do these things and add other joints that travel in a different joint space that gives us these kinds of attachment points. But we are not done yet, because I like to keep this stuff sort of clean and separate, and it's a great opportunity to introduce a couple other ideas. So far, we have done all of this inside of our character's primary animation blueprint, but we can leverage some new stuff that came in Unreal Engine 5, which is our post-process anim blueprints. And with those, what we can do is we can take all of this out and keep it in a separate blueprint that has just the additive stuff we're doing for virtual bones or our physics simulations or whatever we want to do. So let's go ahead and do that. So in our meshes folder, I'm going to right click on my Mani. I'm going to create a new anim blueprint, and I'm going to call this Mani post ABP. Okay, and what we're going to do is we are going to do a couple things in here. The idea here is this blueprint is going to be run after all the blueprints run, and the way we set this up is we add it as a post-process anim blueprint to our skeletal mesh. But before we do that, let's at least make it work. So what we need to do is we need to get our input pose. This is where it starts from, and this is basically going to take whatever comes in and do whatever we need to afterwards. So what we'll do is we'll go back here and let's copy all of this stuff out of here, and we'll put it into our post-process one instead. Okay, so we're going to connect our control rig in. When we do this, the minute I click compile, we should see this virtual head bone that's at his head right now pop up in space. But no, it doesn't, because we don't actually have these variables defined yet. So let me copy those over too. This is my blueprint, variables, compile. There we go. So now that it compiles, the virtual bone pops up in space. This is cool. So now we have that. Now we just need to connect this in by leveraging this as a post-process anim blueprint. So what we do, where we do that is, let's compile and save this, all of this. So you'll notice when I compile this, you'll notice in the base blueprint, the head virtual bone is now where it was by default. We can save that. And if we go to our character skeletal mesh, over on the left, hidden down, there is a post-process anim blueprint option right here. Hopefully you all can see that. All right, and in here, this is why I usually put post-process. Actually, interestingly enough, Quinn has a post-process. We are going to use ours, Mani post-process ABP. All right, and you'll see the minute I connect that in, that virtual bone pops up. So now what we've got is we have all of the stuff that we were doing before, but our rotation's not working yet. And the reason that's not working is because in our Mani post-process, we're not actually setting this actor rotation. So we do need to go back to our event graph, grab this stuff. We can disconnect this because we don't need it anymore, and we'll move this to our post-process event graph, update animation. So connect that in. Compile. Because we don't have our actor, and the character is here. So let's get character. They're using the player. We'll just try getting the owner. That should do it. So we have now converted a simple on-tick joint placement to using a virtual bone. And the reason for that is because with a virtual bone, we can use a control rig to do cool stuff like position stuff arbitrarily in space, as well as counter animate or counter rotate based on our character's rotations and things like that. And these are all things that we can turn on and off and set based on values and all that kind of stuff, just depending on what it is you're trying to achieve. In its simplest case, this is a great way to do an overhead VFX attachment that is not rotating with the animations that are happening underneath. whether you use it for VFX or status symbols or whatever you want. This is cool. As another example, for example, if you wanted to, you could create another virtual bone. Let's do it real quick. Let's create a virtual bone that kind of tracks our center of gravity. So let's add a virtual bone, and we're going to put it, let's put it at spine 3. Okay. And then what we'll do in our control rig is, actually, let me go back and save this real quick. In our control rig, in our rig hierarchy, we're going to refresh this. Where is it? Refresh. And this is going to be our manis. Oh, I messed that up. Oh no, I broke it. Let's do that again. Refresh with mani symbol. Okay, cool. So now we're back and we have our virtual bones down below. So what we can do, another simple control rig thing that we can do, is we can constrain this bone. So what we're going to do is we are going to set the bones translations again, and we are going to use, let's see here, let's do a constrain. We are going to do a position constraint. And the way a position constraint works, actually we don't even need this. We're going to do in here, the name of the joint that we're going to be positioning constraining is going to be our virtual bone, spine 3. I'm not going to maintain the offset because I want it to be absolute. I want it to be the absolute average. And what I'm going to add in here as the parents is I'm going to add in, let's do the head. Let's add another parent. Let's add in the hands. Let's add in both hands, actually. Hands left and hands right. That's probably enough. You know what? Let's add maybe the root. Let's add the root too. Okay, so what is going to happen with this, not a root? So what's going to happen with this is going to be setting the virtual bone root spine 03 to be a positional average of the head, the hand, both hands, and the root. So if we look at this when we compile, we should see this virtual bone. You'll notice that it's right around the pelvis. Okay? So as our character animates, if our character were to reach over, this joint would, this virtual bone would actually kind of do a weighted average of the position. And it's kind of an interesting way to keep track of maybe where your character's center of mass is, depending on how you weight all these things. So just two, quick little things. You can set bones translations, you can set the rotations, but you can also do things like constrain using control rig. And these things are all available to you. So that is a quick intro summary to virtual bones using control rig, a post-process, and a blueprint. Now, before I move on to the next section, which is doing this in a thread safe manner, which is kind of like next level performance concern type stuff, does anybody have any questions about what we're doing so far? It's crickets in the chat so far. So either everybody's like, what are we doing? Or this is awesomely boring. All right, still crickets in the chat. So either the stream's not working or, like I said, one of the other two options, but we're going to keep rolling because maybe... Okay, very cool. Thanks Josh for the heads up. It's good to know you all are still here. What we're going to do is, this is one of the cool things about working with a bunch of just super talented artists, devs, engineers, everything. So Christian, welcome to the stream. Morning from Sydney. Sydney's in the house. That's great. Okay, so we've got our virtual bone, we've got our post-process Anim BPs, we've got our control rigs, we've got all this stuff working. What does next level look like? How do we do this in a thread safe manner? What the heck does that even mean? And why would we want to do that? So remember when we started, we did this using the BP's third-person character on tick. That technically, I believe, happens in the game thread. What that means is, just look, at the end of the day, just understand its performance. There's only so many things that you can do in one tick of a frame in a specific thread without having impact on performance. So there's lots of balancing and juggling that happens in the development process of, you know, when do things get calculated, when do things get animated, changed, etc., and they happen in threads. What is a thread? All right, the easiest way to think about this is, in the old days, a computer had a CPU in it. It could do one thing. It had one brain. That's all it could do. And everything had to be done by the CPU. Well, then they added the GPU, the graphics card. So what happened was, now they had two things that they could use to do calculations. And there was a huge movement to do as much as possible, for example, for all the graphics and drawing and everything like that, on the GPU. That's your graphics processing unit that's on your video card. Well, then what happened was they started coming up with new tech. They got faster and faster, and now most of your CPUs are multi-threaded, meaning they have 16 cores, 8 cores, whatever it happens to be. And so you have 4 brains that can all be doing different things. And so as this has all come about, what they did is they started setting it up so that there are different threads that are doing all of the calculations to display the final experience or game that you have on screen. There's the game thread, there's all kinds of different threads. Well, one of the things that you can do to leverage this threaded workflow is you can basically offload things, or you can make sure that it works multi-threaded, so that, for example, if we are all in the game thread and the game thread is using all 4 cores, how do we make it so that we use all 4 instead of just stacking things up one at a time? That is like a small sliver of what goes into performance, what threading actually means, but the general gist of it is we want to be able to multitask. We don't want to have to do X then Y then Z, because it takes longer if we can do X, Y, and Z all at the same time if our hardware lets us. So, generally speaking, most people, well, I don't know, maybe not. Maybe you all already knew about multi-threaded and how to properly implement an animation blueprint update using multi-threaded. I did not. Some very talented engineers at work opened my eyes to this, so I'd love to share it with you all as part of an interesting part of this. So generally speaking, this event update animation blueprint, I believe it's happening in the game thread. We would like to make this multi-threaded, and we can. So to do that, what we're going to do is, in our functions, we have 5 overridable. And the one that we want is, we want the blueprint thread safe update animation. Now, there's some interesting things about thread safe updating of animation and some limitations in how it works that is not super obvious to get to wrap your head around when you first start. I'm not going to get into all of them, but I am going to show you how this specific case works. Okay, so what we're going to do is this actor rotation. What's this warning? Evaluates the control rig. Thank you, that's good to know. What we're going to do is we're going to take this setting of the actor rotation out of here by disconnecting it. All right. LT, we'll get to general questions at the end as soon as I'm done. I'm almost done. We actually have some time for some open Q&A today. Also, I brought some Q&A from the Discord as well. So I've disconnected our Anim blueprint. So what that means is our rotations are no longer going to work. So if we were to play right now, the positions would still work, but you'll notice that our rotations don't work. So what we can do is we can go back, and now to do this in a thread safe way, all we want to do is set the variable, but we can't access the character the same way here, but we can do it through properties. So if you just type property, and you'll notice there's a variable called property access. And in here, what we can do is we can get the owning actors rotation. Actor rotation. We can get the owning actors rotation. And with that, we can set our rotation. And this is going to update, but in a thread safe way. And the general rules for this, actually, there's actually some pretty good docs on the Unreal doc stuff that kind of explains thread safe use. But the general gist is you can't access the character directly. You have to do this property access, and any functions you use in here, you also want to make sure are thread safe functions in order to properly, capitalize on all this. When I compile it and set it, now we have it, and now we're back to countering our rotations because our rotation value is now being set in a thread safe manner in our post process Anim blueprint. So that was a whirlwind tour of Virtual Bones, sockets, post-process Anim blueprints, an intro to just the idea of a thread-safe animation update, and I don't know, a bunch of other stuff. So that kind of wraps up the actual live tutorial for today. Like I said, I have a couple of Q&A stuff from the group about skeletons specifically, so I'm going to show you all how to orient a joint, for example, in Maya. In fact, I should probably start Maya while we're doing that. And then in the meantime, let's see if you all have any questions in the chat. Okay, so LT, welcome to the stream. I can't copy and paste objects to a blueprint actor, like let's say I import a 3D model body, then want to take the head of my meta dude and transfer it to it will not paste, like I never copied it. So copy and paste in Unreal. Okay, hold on a second, Josh, I'll get that. Copy and paste in Unreal does great with blueprints. If you wanted to copy and paste an actual skeletal mesh or a mesh itself, you would have to import that as a separate piece, because you're not going to be able to just, for example, tear off the character's head and attach it to somebody else. You'd need the head as an individual piece that you could attach. So would a virtual bone be handy for, say, displaying a gamer tag? It could be, yes. That being said, most cases, gamer tags are usually displayed through the UI widgets and things like that. But you could do it. The general main purpose, or one of the biggest use cases for virtual bones, is to use them as an alternate tracking point for IK attachments. So for example, if you have your character's hands on a weapon and you're putting an additive animation on top of it, the problem is if you add an additive animation because of your character's spine and hips and everything connected, what happens is the attachment point for the weapon is going to change. Like if you ever see swimming, it's changing. Well, a virtual bone gets around that because a virtual bone is parented to whatever you want it to be. In that case, you'd probably parent it to the root. It would follow the actual attachment point and would not inherit all the additive animation stuff. And as a result of that, you'd get a solid lock. So we're actually going to do a tutorial on that because they actually go through that in the docs and explain it, but it's a little hard to wrap your head around. So I'm actually going to do a live version of that in an upcoming, or I may do a pre-recorded one. We'll see. But yes, probably the biggest use case is for IK and retargeting and things like that. I've seen them used for status effects, less nameplate stuff, like maybe a little fire symbol or something like that. And then, like I said, the big one is the VFX teams. VFX teams always ask me for this. They always want these sockets all around the character that they can use to attach their VFX to in different ways. Sometimes they want it to rotate with the character, sometimes they don't. That's generally where that comes from. Okay. I'm wondering about the fixed rotation. I was thinking about health bars, etc. You'd want them facing the camera. Exactly. So a health bar generally is done, depending on how it's implemented, it's done as a widget, and a widget faces screen space, so it faces the camera. But you could use this, and all you would do is you would get basically you could get a vector from the enemy, for example, to the player, and use that rotation rather than using the actor's rotation counter. You with me? So you could use that as the rotation, and then it would always face the camera, and still be fixed in space, which is kind of cool. Because one of the things that happens with widgets is if you eject while you're using a widget, what ends up happening is the widgets go off all crazy because they don't know what space they're supposed to be in. Okay, it's the same with the custom blueprint. Like if I go into an animation part, I create a custom made animation rotation, then I try to copy and paste it under so I don't have to rewrite it all. Will not paste if I have to. Okay. I mean, LT, I would say you're welcome to hop in Discord, throw your question up in the Discord channel. In general, Unreal is really great. Actually, here's a quick little tip for all of you. If I bring up a notepad, I love this actually. If I bring up a notepad and we delete all this, you can actually copy and paste your blueprints into a notepad. You're like, wait, what? So if I take all of these nodes and I Control C that and I go back to my notepad, where'd it go? Here it is. I can paste it in here. It looks like a whole bunch of gibberish, but now that it's in there, I can come back to this blueprint. I can highlight all this, Control C it, and in here in empty space, Control V it. And now I get all the stuff that I copied and pasted. So not only can you copy between blueprints, but you can also copy to, like I can just Control C this guy. I generally can Control V into here. Oh, that doesn't work because I was pasting it in the, not in the anim graph. Let's do that again, in the anim graph this time. There we go. So it'll paste in the anim graph. So it matters which one you're pasting it to. But so not only can you paste between blueprints, you can also paste into a notepad and then paste that into something else completely, just in case you didn't know. One thing to note is as you get deep into the depths of an anim graph, some of the way the numerical indexing works is it can get kind of funky. Be careful. Sometimes it's just easier to rebuild because copy paste doesn't work. Oh, that's good to know, off the rails. Okay, so if you all don't have any more specific questions in the chat, one of the questions we got that also pertains to skeletons that we can go through is, how does a joint get oriented? This was left over from our last tutorial. We talked about how in Unreal Engine, as a recap, if we're looking at the skeleton, when we pick any of these joints for our character, you'll notice that the X points down this axis, Z points out the shoulder, and Y points forward. How do we set that up? Each of these joints is set up in that way. So I was going to do a quick demo of how that works in Maya. So let's just, in Maya, and this is generally the same for most DCC tools, but the idea is you'll generally create some joints. So let's just create an arm, for example. And we're going to totally mess this up at first just to prove out the point. Okay, so this is our shoulder. And by default, when we create joints in a lot of digital content creation DCC software, you'll notice they'll auto orient. So if you pick this, you'll notice that X already points down the axis. All right, it doesn't get funky till we start moving things. So let's just say that I wanted this to look like my character's shoulder. So I'm going to move this up in space. I'm going to move this back. I'm going to move my elbow down so it looks like it's more in an elbow position. And this is going to be the wrist, for example. Well, now, if you're in object mode, there's two modes, just like in Unreal Engine. You can change your manipulator. This is world space, this is object space. You'll notice now in object space that this shoulder joint, if we rename this to shoulder just to be clear, you'll notice that this shoulder joint is not pointing down the length of the axis anymore. How do we orient this joint so it points down the length of the so the axis points down the length of the bone. English. All right, for the win. Well, you use, generally speaking, there's a couple different ways. You can do it manually or you can use a tool. So let's start with the tool. So in Maya, underneath skeleton, there's an orient joints tool. And in this tool, there's a bunch of options. you basically pick your primary axis, you pick your secondary axis, and what your world orientation is going to be, and you basically click apply. And when you do that, what happens is it updates so that X points down the axis, Z points forward, and Y points out the shoulder. And in this case, we have X down the axis, Z is out the shoulder, and Y is forward. So if we wanted to flop these, we could click that and apply, and we could change this to negative. And now, we may not be able to get there. I think that may be a conversion thing. Okay? So, overall point is through these options, you can use the tools that are built into your DCC app to do this. You can also do this manually, usually. And a lot of studios write their own tools to do this because they want maximum flexibility, and flexibility is one thing, but they want absolute repeatability and control over which way the orientations of these joints are facing. So let's do one. We have enough time. Let's do one by hand just to show you what the manual process looks like. So let's undo this. So the way this works to do it manually, typically speaking, is you unparent the child. Now this joint is free. And what we're going to do is we're going to use a couple other tools to help us. We are going to aim this joint to point at the elbow. So I'm going to pick the elbow, pick the shoulder, and I'm going to choose constrain aim. And when I do that, you'll notice that my shoulder joint is now aimed perfectly at my elbow. That's what we want. So what we need to do is we need to take all of these rotations that are now as part of rotation, and we need to move these down to our joint orients. Okay? And the reason we need to do that is because we want no rotations on our joint itself. So what I'm going to do is I'm going to delete the aim constraint, and we're left with the shoulder with all of our rotations. So if we just take this rotate X value and copy it down to the joint orient, Y value joint orient, Z value down to the joint orient, and then we zero out all of this stuff, what you'll notice is our joint is now pointing at the elbow, right? X is down the axis of the joint, and we have 0 rotations on our shoulder, which is cool. And then all you do is parent your elbow back in, and now you have a properly oriented joint that you controlled specifically. Now, one of the reasons I showed you that is because that understanding of how that works, being able to calculate which way this would need to face and copying those rotations into the joint orient, basically the buffer, if you will. Different applications do this a different way. You can now build your own tool so that if you wanted to be able to control which way this Z-axis was facing, you could. But once again, that was one of the questions that popped up in the community as far as how you would orient a joint that I thought would apply, since we've been talking about skeletons and virtual bones and all those kinds of things. So let me double check my notes to see if I had anything else for you all today. Otherwise, we can wrap it up. Yep, that's it. That's what I had for our live tutorial today. Did anybody have any questions before we wrap up today? Let's see here. Would you be willing to do an animation set for me, like a tutorial? I want the animations of Ghost Recon Wildlands, but a tutorial. An animation set is an insane amount of work. Just so you know, it's that. I mean, that is not a small ask. So I'm sure there are people out there that would do it, but you're asking someone to spend a lot of time to build a set like that. Just as a general heads up. Have a great one, Off the Rails. All right, y'all. with that, don't forget, we have the Patreon, we have the Discord. I generally try to hop on at nights, at least a few days a week, stream just my own dev work on my own stuff that I'm building. Sometimes we'll answer some questions, stuff like that, so you're welcome to hop in those as well. We should be back next week for at least one more of these before Christmas vacation or the holidays, depending on where you are in the world. And as always, you all are the reason we're here. Thanks for being a part of this community. Thanks for watching the videos, taking the time to check them out. All feedback welcome. Throw it down in the comments. I use those to figure out what other videos we might be doing and also course correct so that this information is useful for you all. I hope everybody has an awesome rest of your week, good weekend and stuff, and I will see you hopefully in an upcoming live tutorial. Have a good one.